All right, hello ninth graders, this is Mrs. Johnson. Um, we are on page 16 for the regular ninth graders. Honors ninth graders, slightly off, but I'm sure you can figure out which page of notes it is just by looking for comparing data sets. Okay, so do you remember Rachel from yesterday's notes? Well, Rachel decided that looking at the data together with her and her mom's friends wasn't really fair. She claimed that her mom's friends naturally sent fewer text messages. Like, for some reason, she thinks that old ladies might send less texts than like young teens. I don't know where she got such a wild idea from, but it might have something to do with the fact that like Mrs. Johnson probably sent like 3 text messages yesterday. And if you have a cell phone, I am willing to bet that maybe you also sent 3 text messages yesterday. Who knows? All right. Or maybe teenagers send a lot more text messages and Rachel might be right here. So is there evidence of Rachel's claim from the data displayed yesterday? So what data or what evidence did we have from yesterday? Well, yesterday's data looked like this. We had 2 main peaks and we called it bimodal. Okay, so was there evidence? Yes. We're going to write that in here. Yes. The data was split. We could clearly see that there was a big chunk of data that was low and a big chunk of data that was up higher. So if we were to find what bimodal is, it means 2 modes. And in parentheses, I'm going to say 2 main peaks. Okay, so bimodal, 2 modes, 2 main peaks. So let's break this data up into Rachel and into Rachel's mom. So Rachel decided to investigate the data separately by creating a box plot. Now, ninth graders, we talked about box plots quite a bit in the 7th grade, so we're going to do a little bit of review on box plots. She's going to make a box plot for each set of data given below. She even put them in order for you. That was really nice of Rachel. Okay, so a couple reminders. Let's talk about minimum and maximum. So if I were to look at this data, I know that the minimum is going to be the low, oh, that's a bad pen. The minimum is going to be the lowest value. It's going to be the lowest value in the data set. The maximum is going to be the highest value. Highest value in the data set. So if we were looking at Rachel's data, her minimum is going to be her lowest value, and over here that is 0. So I'm going to write min underneath 0. And then I'm going to come over here to Rachel's maximum, and I'm going to make it 150 for the maximum. Okay, now for Rachel, that was for Rachel's mom's data, by the way, not Rachel's. For Rachel's data, it was 36 for the minimum and 275 for the maximum. Okay, so let's look at the median. Now the median is going to be the middle value of the data set. So I'm going to call that middle value. Now, sometimes, like there are calculators out there where when they say median for middle value, they're talking about quartile 2. And they'll even call it Q2. And sometimes we'll call the minimum, well, we'll get to the next part. We'll call we've got a first quartile and a third quartile below. So to get that middle value, I've got to look at the exact middle of the data. Now I could take my fingers and say, okay, these are on the outsides, move in, move in, move in, and I could find the middle by sliding in every time. I often lose track, so I'm actually going to count up how many data pieces there are. I'll split that in half and find that middle number. So 1, 2, 3, I feel like we already knew how many there are, but I'll count in case. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yeah, for some reason I feel like yesterday we were told there were 24 data pieces, but regardless, half of 24 is 12. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I'm going to have a middle right there. You'll notice I drew a line in between those last two sixes. Above that line, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, there are 12 numbers below that median, 12 numbers above that median. Now, every once in a while, I don't have a nice split like that. Sometimes, let's say there were 25 data pieces, and this was actually a number in the middle. Well, instead of drawing a line in the middle of that number, I would just circle that number as the median. So currently, we don't have an exact number in the median, so we have to take the average of the two numbers around the line. Well, to find the average, you add two things up and you divide by 2. So I would add up 6 plus 6 and then divide that answer by 2. Now, every once in a while, people type that in like this: 6 plus 6 divided by 2. And then they say, yeah, 9 is definitely the average of 6 and 6. Ninth graders, we got to use our brains here. Your calculator follows the order of operations: parentheses, exponents, multiply, divide, add, subtract. Your calculator divided 6 divided by 2, and then it added to 6. It's because your calculator is not smart enough to read your mind. So if you really want to type it in like that on your calculator, you better put parentheses around your 6 plus 6. And when you divide by 2, you get 6, because the average of 6 and 6 is 6. All right, so I'm going to put the number 6 as my median. I'm going to put on a little popsicle stick, and that is Q2. Use that same method to find the median for Rachel. So count up where 24 is, split it in half. Push pause and do that. I'm going to push pause and do that as well. All right, hopefully you did push pause. When I counted 12, I had 12 numbers below this line and 12 numbers above this line. So I'm going to add up those two numbers and divide by 2. So I have got 143 plus 145 divide by 2. And I get 144. So my Q2, or my median for Rachel, is 144. All right, now I need to get the lower quartile, which we also call quartile 1. Down here I'm going to call it, actually, I'm going to change color. I'm going to call it Q1. And Q1 is going to be the median of lower half. The median of the lower half of the data. And then for the third quartile, we'll call that Q3. That is going to be the median of upper half. All right, so let's find those medians. Now, for Rachel's mom, there were 12 pieces of data here. If I split that in half, there are going to be 6 numbers on both sides of Q1. So 1, 2, 3, 4, 5, 6. There's my Q1. And between 5 and 5, I've got the number 5. That's pretty simple. Up here, 1, 2, 3, 4, 5, 6. Split it in half there. That will be my Q3. And between 15 and 16, the average of those two, I could add them up and divide by 2, but I also know that 15.5 is halfway between those two. That's not crazy or difficult. You are going to find Q1 and Q3 for Rachel. Please push pause and do that, because I'm going to do the same thing. Okay, so I found the Q1 for Rachel, and it was between 130 and 137 because there were 6 values above and below that. And when I added up 130 plus 137, and then I divided that answer by 2, I got 133.5. Same thing down here for Q3. I added up 150 plus 155 and divided by 2, and I got 152.5. So I just split the top in half and I split the bottom of the data in half. Okay, now we are going to plot these on the graph below. So I'm going to start by, we'll start with Rachel's mom. I'm going to put her minimum, Q1, Q2, Q3, and the maximum on my number line here. So the minimum for Rachel's mom was 0. So I'm going to draw a dot there and write a 0 above it. 1 second. All right, so I've got the minimum there at 0. Now I'm going to put the maximum at 150, which is right about here. I'm eyeballing it, which is why it's very important for me to write the number up above, because it's hard to tell if it's exactly at 150 or if it's at 151. There's also some dude outside the window blowing leaves. but now my window is closed, so yay. All right, I'm gonna get the next few things on here. Q1 for Rachel's mom is at 5. Now these are counting by 5, so the dot will go directly above 5, and I'll write a 5 there. And then Q3, I guess I should go for Q2 next. Q2 is like weirdly directly after the 5 because Q2 for Rachel's mom, or the median, was at 6. So it's gonna be just barely past 5. Then Q3 is at 15.5. So we've got 5, 10, 15.5 is like barely past 15. So in the 7th grade, we told you how to connect these. The 3 centered dots make the box of your box and whisker plot. So I'm gonna put those into my box like that. I drew a box around them with 3 lines. So you can draw 3 vertical lines through the 3 middle dots and then connect them as your box. Then your whiskers extend in both directions. Okay, so that was Rachel's mom. Now we want to make sure that whoever's looking at this can tell that that was for Rachel's mom. So next to this, I'm going to label Rachel's mom. Notice I spelled Rachel wrong. It's because I am a poor speller. So let's put that L in there. Rachel's mom. Okay, now let's put Rachel's graph. And there's currently not a lot of space for it. There's 2 places we can put this. Sometimes, and I'm guessing that's what this paper wanted us to do, sometimes we'll graph it up above Rachel's mom's, so they'll be stacked. Other times we'll graph it directly below so that you have some more space. I'm actually gonna graph below because I like it better. When we're looking at the 2 sets of data and comparing them. That way it's easier for me to eyeball where those tick marks are instead of guessing and going up even higher. So the minimum for Rachel was 36. So I've got 25, 30, 35, barely past that will be 36. The maximum for Rachel's mom, or for Rachel, was 275. So that would be the very end here, 275. Okay, for Rachel, the median was at 144. So here's 125, 130, 135, 140, almost to 145 would be 144. And then for Q1 and Q3, I've got 25, 30, 33.5. You can come in. And then for Q3, I've got 152.5, which is just barely past 150. All right, draw in your box plot, and we will go over that in just a second. All right, hopefully you got those on there. Sorry that I keep having to pause this. Mr. Bodley keeps interrupting. If you're in his class, you can just give him like a shame right now. Ugh, that guy. He's the best. All right, so let's draw our 3 lines in the 3 inner dots here. 1, 2, 3, and then I'm going to connect these to make this my box. And I can extend out to the maximum, and I can extend out to the minimum. Now, if I'm looking at these 2 sets of data, is there an argument that can be made here for Rachel? Let's look down here. Based on the 2 box plots above, help Rachel, oh, hold on, I forgot to put a label for Rachel. That's Rachel's data. Help Rachel construct an argument about how many text messages she should be allowed to send in 1 day. Make sure your argument includes 3 mathematical reasons why you picked that particular number. So I want you to look at that data and say to Rachel's mom, hey mom, this is how many texts I should be able to send in a day. Now, I'm talking to you, the 9th grader who's literally watching this video right now, pick a number. On this data, how many text messages should Rachel be able to send? And I want you to tell me 3 mathematical reasons why you chose that amount and why that was reasonable for Rachel to be sending. All right? Pause the screen and write down 3 answers. Okay, hopefully you actually did what I said. So where are the majority of Rachel's friends? Most of her friends send inside this box. Because remember, we split the data into 1, 2, 3, 4 pieces. So if we split it into 4 pieces, between this and this, you had 2 of those 4 sections of people. That's 50% of the people. 50% of the people fall between Q1 and Q3. That means half of Rachel's friends send between 133.5 and 152.5 texts. Now, how do you send half a text? You don't. These are averages, okay? An average can be half. So that many texts, I would say 133.5 through 152.5 texts, because half of Rachel's friends send that many. Half of her friends sent that many texts. That doesn't seem unreasonable to be able to send texts where half of her friends are. Now, if you were one of those people who said, oh, Rachel should be able to send 275 texts because, like, she has a friend who sent that many, why might her mom argue that 275 is not a very good representation? Similarly, if Rachel's mom were to say, well, Rachel, you had a friend who only sent 36 texts in a day, what would Rachel's argument be? What do we know about that maximum and minimum compared to the rest of the data? Does it really fit in to where most of her friends are? No, we sometimes even call those outliers. So we're gonna say the very high, and I'm gonna underline very, the very high and low numbers look like outliers. The word outlier, it means it lies away from the rest of the data. Okay, now if you really had to choose one text, I might go with the middle number. The middle number is 144. So we could say 144 texts could be a number, and I'm going to say it's the median. And that seems realistic if she were to say, hey, Mom, the middle amount of text that my friends send is 144. Maybe her mom would say, gosh, Rachel, what a great argument. How mathematically sound my daughter is. She might say something like that, but who knows? I'm not in their family. Okay, so let's look at the second page of notes. I want you to put page 16 to the side, and we are going to pull out page 17. You'll notice one of them's like written really bold and one of them's not very bold. It's because I was using a marker and then I started hating how the marker looked. It was fun times when I was labeling these. Okay, so let's look at this. This is no longer a box plot. We're now looking at a dot plot. Rachel made dot plots out of the text message information. It's shown below. Use the dot plots to answer the questions. So, first question, what is the mode of each data set? Now, I'm going to define the word mode here over in the question/notes. A mode is the most common data value. That is going to be whichever one shows up the most. Now, sometimes you have 2 amounts that are showing up the most. Sometimes you have all of the numbers show up a single time. That would be no mode. So on this one, what is the mode of each data set? So we're going to start with Mom, and then we'll have Rachel. The mom's mode looks like it's right here. What number is repeating all those times? So if I were to look back at the mom's actual data, it's this 5. 1, 2, 3, 4, 5. There are 5 5s that show up for Rachel's mom. So the mode would be 5 texts. And for Rachel, looks like the mode here is 150. And I can see that there's 1, 2, 3, 4, 5 of those 150s. Whew. So maybe Rachel would say, Mom, I should be able to send 150 texts, and you can send 5, Mom. By the way, if someone told me that I could send 5 texts in a day, I'd be like, oh man, I got to find 2 more people to text, because that's a lot of texts still. As you get older, like, you just don't want to talk to a lot of people. It's a really fun part in life. I Hope that you look forward to that time in life. Okay, so we've got the mode here. By the way, don't tell your mom that I told you that we don't text a lot, but the answer is we actually don't, unless we're texting you all, which my kid's too young to text. Okay, so let's talk about what comes after mode. The next thing is the mean. So I'm going to write down mean here, and mean is going to be when you add up all data and divide by the number of data pieces. Sometimes I say divide by the number of numbers. So what does that mean? Well, let's look at Rachel's mom. We're going to write mom, we're going to write Rachel, and we will find their data. So if I were to take all of Rachel's mom's numbers here, and I were to add up 0 plus 2 plus 3 plus 3 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5.5 plus 6 plus 6 plus 6 plus 10 plus 12 plus 13 plus 15 plus 15 plus 16 plus 20 plus 25 plus 35 plus 150 plus 150, I would actually get this number, 517.5. That would be the sum of all those numbers that I just shouted up. And I'm going to divide that by the number of numbers that there are. And there are 24 numbers. So I'm dividing that by 24. I always want to see this fraction. I want to see if you got a wrong answer, why you got it wrong. Because typically it's because we added up the numerator incorrectly. So when I divide that, I get, let's type this in, I've got 517.5 divided by 24, and I get 21.56, and we're gonna round that up to 21.6. So I'm gonna say approximately 21.6 texts. Now for Rachel, I would have to add up the numbers 36 plus 70 plus 80 plus 85 plus 110 plus 130 plus 137 plus 138 plus 138 plus 140 plus 142 plus 143 plus 145 plus 150 plus 150 plus 150 plus 150 plus 150 plus 155 plus 162 plus 164 plus 165 plus 175 plus 275. And when I add those numbers up, I get 3,340, and there were 24 of them. Now let's divide that and see what we get. 3,340 divided by 24. And I get 139.16 repeating. And I'm going to round that to 139.2. Again, right in that ballpark for how many texts that Rachel was begging to be able to send in one day. Okay, which is the best measure of central, or which is the best measure of center to represent Rachel's mom's data? Explain your choice. Now, I want us to look at Rachel's mom's data here. Do you see how all of her dots are really low? They're all like below 25 almost, except 1, 2, 3 of them. So because of those 1, 2, 3 that are above 25, look at how far these are. These are like two really cool moms who send a ton of texts. Maybe they like have a job that makes them text a lot. I don't know. 150 texts. I would die if I had to send that many texts in a day. So when I look at the mean for Rachel's mom, 21.6 texts, that's like right here. Ninth graders, 21.6, that's not really in the middle of the mom's data. The mom's data is definitely mostly down here. And if I go back to, where is it? This box plot that I had for the mom, look at this data is all like 3/4 of the data is below 6 texts. 75% of the mom's friends sent 6 or fewer text messages. So when we say that the mean is 21.6, ninth graders, that's skewed. That's not a great representation. So it's not a good idea to go with the mean here. It'd be more accurate to go with the mode or the median. Now, since we only showed the mode and the mean here, I'm going to just say the mode. And I'm going to say the mean here is pulled up. So what does that mean? Well, if I look at this data for Rachel's mom, this mean got pulled up by these outliers. Let me give you an example that's kind of similar to this. What if you lived on a street, and let's say that your street was made of boxes, and everybody who lived on your street lived inside a box. Now, think about how much your box house would cost. Like if you actually had to go buy a box from the Home Depot, surprisingly kind of expensive, like $2. So you have a $2 home. And then on your street where everybody has $2 homes, someone moves in and builds a $1 million beautiful home on this box street. Okay, then someone comes in and says, what's the average price of homes on the street? Well, you add up 2 plus 2 plus 2, and let's try this. Let's say there are 5 boxes and then this $1 million house. 2 plus 2 plus 2 plus 2 plus 2, that's 5, plus 1 million. And then remember, there's only 6 boxes on the house, so divide that by 6. So the average price of a house on this street is clearly, what is this, $166,000? Like clearly that's not true. There's one really nice house and a bunch of box houses. So that $1 million house would skew the data up. Similarly, if you lived on a $1 million street and then someone came and built a box house next to these $5 million houses, it's going to drag the average price down on your nice street. So these outliers, these things that stand very far away from the rest of the data, are going to pull the average up and down. But the thing that they do not affect is the mode. And they don't always affect the median either. So the median and the mode are going to be better sources of central tendency than the mean, because when there's an outlier, the mean gets pulled one way or the other. Now, if there are no outliers, then the mean, median, and mode will all be very similar. Okay, so which best represents Rachel's data? If we look at Rachel's data, the mean and the mode are very similar here. So you could say either. Rachel did have an outlier, but hers kind of went in both directions. So I'm going to say either. The mean isn't pulled far up or down. Okay, so what are the benefits of a box plot? Well, one thing that a box plot does is it shows where the middle 50% of data is. And that's a really big thing. And another thing a box plot does is it shows how spread out the data is. Okay, some of the benefits of a dot plot that's not a box plot. A dot plot shows you every single data piece. So I'm going to say see each data point. Another thing that a dot plot will show you that a box plot does not is you can see the mode because you'll have a nice peak. So I'm going to say highest point. Benefit of a box plot, benefit of a dot plot. All right, 9th graders, that was page 17 as well. When you go to record or take a picture of these, make sure that we can see both pages. Otherwise, we'll only give you half the points. So please make sure that you are doing this correctly. We will see you later, 9th graders.